Okay, good afternoon, everyone. Thank you for attending this World of Wood webinar. Today we're going to be hearing from Shingi Tarirah and Steve Wallis on the timber beacon that was due to go into COP26. But unfortunately didn't make it because of the issues with planning and everything. So we're actually now hoping that it's going to be used at the London Design Festival at some point in the not too distant future. But a really interesting project. We wanted to bring it to you because there was a lot of innovative ways that I was looking at to try and make this this project work, and sort of incorporating responsible sourcing and circular economy principles into that. So I'm going to hand you over now to Shingi and Steve. So Shingi's from dRMM. Sorry, Shingi's from Whitby Wood Engineers, apologies. And Steve is from dRMM Architects. So I'll hand over to you guys and look forward to your presentation. And I'll turn my video off now so I don't interrupt and disturb you. So thank you very much. Hand over to you guys.
Thanks, Charles. So yeah, this is a bit of a tandem presentation between Shingi and myself as engineers and architects for the Timber Beacon project. We'll just kind of run you through some slides and take it in turns, I suppose, giving our perspective on the design and our proposals for the Timber Beacon project, which, as Charles said, was a commission to look at a temporary pavilion specifically for the COP26 conference, which you would have known was in the news up until last week or so. The idea being that it would be an ideas generator, a conversation piece, hopefully an exhibition on the brilliance of timber for the construction industry, and an innovative proposal to get people thinking, and that the structure itself would then travel to other exhibitions or conferences being reconfigured and shipped around. So we can talk about all those aspects. Cool. Well, I'll give an introduction to dRMM first. So this is a photograph of us in our studio here in Tooley Street in London. So we're a design-led architectural practice. They've been established for 25 years, I think. We pride ourselves on I suppose being a multi or an international office, and so there's 20 odd nationalities. We're just over 50% female to male ratio, and we're won lots of awards, but we tend to build the projects that we design, which is really important as well. And so we've got a track record of working with CLT, and you'll see from the image there's some 1 to 20 scale models of one of our buildings that was made of CLT also. So innovative use of timber is kind of cored into our DNA.
I will give a brief introduction to Whitby Wood and who we are. So we are a young company, but we've done a lot in the time that we've been in existence, and we are mainly across 4 countries in the UK, India, Italy, and in Serbia. And we are most proud of the work that we're doing at the moment to be on our route to certified B Corp certification, which for us is really important in terms of holding ourselves accountable for the kinds of designers that we are. And as part of this process, we've understood that in order to walk the walk about the things we talk about regarding sustainability and how we think about materials, we have to fundamentally change how we think about ourselves as a business. And we don't have to just consider our commitments to our shareholders, but we also have to make strong commitments that we hold ourselves to account for to the environment and hold ourselves responsible for the buildings that we put out into the world. The next little, no, sorry, go ahead.
Go, Shingi, please.
I'm introducing you a little bit, which is we just want to talk through with you guys a little bit about our ethoses as practices and who we are and what we think is most important and what we bring into the built environment through our designs. And dRMM, go first.
Thanks, Shingi. So as an architectural practice, we're particularly interested in the three Ps, people, place, and planet. And I think that by focusing on these three elements, you can pretty much set out your stall and create really innovative but also appropriate design solutions. So Shingi, if you want to press on. Obviously, people is who we're designing for, by and large, and we think it's really important to recognise the audience of our work, and that's communities, neighbours, residents. The people are at the heart of the design thinking within the studio. And I think this the reference of creating socially useful architecture is really important to us. I think it's deep within the DNA of dRMM that we want to be socially useful, right back from the early projects of the practice through to the much larger work we've been doing recently. So this slide talks of some of the consultation work that we've done with communities as part of the Hastings Pier regeneration, where we consulted widely with the community, asked for comments and feedback on the design brief before there was even a design, and really we engaged with the community to create a much stronger project than would have been there otherwise. So you can kind of see some of the design proposals or demands, I guess, of residents on the right, and then the amazing party at the end of the project. And it's one of the great projects of the studio that whenever we go down to Hastings or speak to anyone that's involved as part of the community, there's a real attachment to Hastings Pier and reference to it being community pier, which is such a nice attribute to have. So people is really important. The next slide is also our Trafalgar Place project, where consultation was a key part. Not so much with residents but the broader community. But on the back of that, it's really interesting to see a really thriving community between the residents that moved into the site. And we think that thinking and understanding about these things early on is really important. Place is the next part. So as architects, I think it's easy to get fixated on the building as an object and not think about the place. And I think within dRMM, we're really interested in thinking about how our interventions create place. So it's not just a master planning aspiration, but certainly something that we can control as architects.
Sorry.
Oh no, that's fine. So these are some slides from generally master planning projects that we've been involved in, but really thinking about the quality of spaces that we're creating and how they can be taken forward. And the final P is planet. And so this is really appropriate for the Timber Beacon project. As founding signatories of Architects Declare, we're really aware of the contribution of the built environment to carbon emissions and the environment generally. And dRMM is particularly interested in how our buildings affect the planet or how we can limit that effect. So a lot of that work is through assessments of materials that we use and building techniques. And it's that research that's led us, by and large, to a lot of our work with engineered timber. So the next project is Maggie Center, which was delivered as hardwood CLT, the first permanent building to be made out of this Maggie's Oldham. And so it speaks of the innovation that's possible when utilizing engineered timber. And I'll leave you to Shingi.
Well, we at Whitby Wood, we think very seriously about the proposals we put out into the world to architects and other designers. And one of the things that we feel is a cornerstone to how we run our business is thoughtful use of materials. And we're thinking a lot very seriously about sustainability. And while that's a much more broad and all-encompassing term of a variety of concepts. We're showing here some of the buildings we've been working on recently that really champion the use of timber, which is something that we feel really passionately about. So, for example, there's the Anthony Timberland Center that we're working on in America, where the idea for this was to create an all timber building that is a tool for education for architecture students at the University of Arkansas. So the building not only facilitates the education of the students, but it can also be used as part of their education. And we're trying to incorporate different kinds of timber into this building so that students can understand how to use timber appropriately and draw inspiration from how we've decided to tackle this as a structural challenge. We're also thinking very seriously about the changes in building codes that have happened recently as a result of the disaster at Grenfell and how that's affecting how we approach high-rise buildings in the UK. And we want as much as possible to bring timber back. So we're trying to include that in as many of our tall timber design projects, like the image shown at the bottom. And also we've been trying to use a lot more CLT and timber throughout our designs, and we've been working with several architects on the Greenwich Design District, which opened fairly recently, I think just a couple of months ago or so. So we're trying very hard to think about creative and beautiful ways to use timber as part of the way that we design, so that we can also contribute to the conversation in a positive way. I'm gonna have to slip to a video here for a second. So we also do quite a lot of research and development to try and help us towards our goal of being more sustainable and thinking about these issues more seriously. And an integral part of that is making sure that we can make the mundane tasks that we have to do as engineers as efficient as possible. And as part of that process, we've been developing a suite of applications that help us make these assessments of our buildings and design them in a more efficient way. So this is one of the apps that we've developed called Compass. So you can put in the basic geometry of a building, and you can include things like loads and fire resistances. And this will help you come up with initial sizes for different schemes at the early stages of a project. And you can also put in things like foundation options. So you can come up with results for the carbon counts and the embodied carbon for various options that we can then use to inform architects and other designers about the choices that they can make and how they impact the environment. As part of this Compass app, you can get graphs that you can map out to see which bits of the building are hardest working in terms of that embodied carbon, so that we know the areas to focus on. And this relates to another application that we have, which is similar to the iStrike app that you can plug into your Revit models. So once you've got your building modeled up, you can get the volume of your material and then get the embodied carbon of that particular structure as an integral part of your design. So that information is always really quick and easy at hand, so that you can give advice to people as quickly as we can. This is an app that we're kind of having some fun with. So we're trying to bring the paper traditional world together with the 3D world. So we want to develop an application where we can use our sketches as an integral part of our design process and immediately turn them into something digital that can be analyzed quickly and easily, so we can get results out there much faster. This is Scaffold, which is our calculation app. So again, we're thinking about making these mundane tasks that we have to do a little bit easier. So a lot of the basic element design that we have to do can be done through this app, and it will consider carbon, and it'll also help us create much more efficient solutions to the buildings and challenges that we have to face. And another thing that we're very particularly passionate as a firm is we want to hold ourselves accountable, like I mentioned before, and part of that is setting targets about what we're doing about our carbon emissions, because everybody is an emitter. And one of the things that we've done is we've set this target that we want to be at zero carbon by the year 2035. So I'll put a link in this in the chat later, but we've come up with a system to help us assess the things that we can do to help us to reach that target. And there are lots of different variables that you see in this app that will affect how we get to that zero carbon target, but we understand at this point that it's a two-pronged approach. It's about the buildings that we produce to people, but it's also about how we run our business as an office. So you can play around with this app and it shows you the different variables that affect this route to zero by 2035 and the things that are most impactful. So if you guys want to have a play with it as well, then that would be quite useful. I think you can get some interesting information out of it. Go back to the presentation. Sorry, I apologize. My PDF is a little slow today. So now we're going to talk a little bit about the timber beacon itself and what our approaches were. So Steve will talk a little bit about what they were thinking as architects when they first got their brief, and then we can talk about what we see as engineers when we first get proposals like this from the architect.
Yeah, so we can probably flick to the next section. Sure. So I suppose our brief for the Timber Beacon project was to create a talking piece, as I said, for the COP26 conference in Glasgow, to showcase the opportunities of engineered timber. Really, and it was quite a broad brief. There were no particular materials in mind at the time. It was really for us to determine what was best. The site for COP26 was right on the River Clyde, or next to the River Clyde, in Glasgow, between the BBC Centre and the Glasgow Science Centre. And I guess the idea that the world was watching, and this opportunity for creating a showcase or a pavilion at COP26 was all about getting the attention of world leaders or diplomats or politicians or those that are attending, to showcase what's possible in wood, and really challenge maybe preconceived conceptions of what was appropriately built from timber. So we wanted to be deliberately bold and large, and really show off the potential of this material. So that's just another view of the site. And we thought there was this wonderful opportunity with this brief to create a particular message for the Timber Beacon. And that's really that in wood there is hope, that as world leaders and the like got together to battle out saving, the world from climate change and the like, and all of this, we wanted to say, here's this material, and there is hope in using it. As the studio's got quite a bit of experience working with engineered timber elements, we thought it was a good opportunity to extend some of the design thinking in relation to architectural relationships. And we thought, particularly given the need to dismantle and reassemble, move the installation between venues, there was a good opportunity to look at I guess the planar arrangement that makes up the work of Gerrit Rietveld, and perhaps the Distill movement in general, and this idea of planes and Cartesian joints that would make it easy to assemble, to disassemble, to reassemble, but yes, use this idea of arranging planes to create form effectively. So onto the concept. So this is an early sketch, really, that looks at this idea of creating a structure that it creates a physical and visual landmark. It functions as a wayfinding tool, I suppose. It challenges preconceived notions, what timber can and can't do, creating this cantilevered element, and creates an enclosed space for exhibitions and talks and the like. And as I said, this idea of defining these three elements: a tower, a canopy, and an exhibition room, and arranging them using this kind of Rietveld manner of abutments of planes and Cartesian joints. And this is then that arrangement kind of first being realized through some sketch models that we produced in the studio. At this point, we were thinking about how the pavilion could be assembled or disassembled, but also how it could move between events. And you'll see the so the three main timber elements. And oh, sorry, Shingi, if you go back. And then the introduction of the shipping container, the idea that the elements all get packed up into a shipping container, taken to the next location, disassembled, the container stands up on its edge and creates the foundation for a tower element, which is the visual beacon element of the pavilion. And then all happens in reverse to go to the next location. In plan, the arrangement was quite simple, I suppose. There's the three main elements which create the general arrangement in three volumes: the container orientated vertically, the exhibition room, which is in the center, and then the combination of canopy, which spans in cantilevers in two directions over the top of the exhibition space, and also provides a ramped access underneath. So the idea being that you'd enter via a ramped entrance, pass by the container that provides some information about the exhibition space on the outside there next to the exhibition room door. And then there's a free flow room, and then you progress out to the right in the image underneath the canopy. So fairly simple diagram, I suppose. Oh, you're muted, Shingi.
Try that again. So I thought I would just summarize what we saw as engineers when we initially saw the sketch models proposed by dRMM. And if you've done a few timber buildings, you will know that timber buildings are quite lightweight, and you have to be quite careful about how they perform under wind loading. And this is even more important for this structure, because if you were to design a building, say, you would have foundations, you would have the ground to anchor your structure into so that it doesn't overturn and fly away. But in our case, we don't have any guaranteed foundations at any of the sites that we were thinking of. So we had to immediately start thinking about tackling the overall stability of the structure and understanding where our mass was coming from and if it was providing us with adequate stability to keep the structure stable. The other thing, which was not immediate at the start of the project, because the structure itself is not very tall, but when you start getting into the nitty-gritty of things, is that the tower element is quite long and thin, and that introduces vortex shedding issues, which you don't normally get for buildings that have a slightly more favorable aspect ratio. So vortex shedding was a really integral part of how we were developing this design as a design variable, because it completely affects the stresses that act on the structure. And we, from the get-go, understood that this has to be constructed and deconstructed several times. So we wanted to use connection details that are simple and easily available. And so having particularly high stresses that those connections can't deal with is something that we were quite concerned about. The other thing is this long cantilever that forms the canopy. So that immediately, the eye immediately goes there from a structural point of view, because we think about the bending moment that acts at the base of that cantilever and how that's resolved in the exhibition space. And also it's unequal on either sides of the exhibition space. So we have to think quite carefully about how that is balanced to make sure that that cantilever works. And as I mentioned before, we'd understood that this has to be constructed and deconstructed. So the connections were really crucial. And it was really important for us to start thinking about ease of access so that people can actually install these without too much trouble, but also that once the structure has been installed, those connections have to look good while they're in performance. So it's something that we started to think about from very early on in the project. I just wanted to add this slide to explain a little bit what vortex shedding is, because it was quite a new term to me, and it might be a new term to some of you who are listening. But this image shows how air flows around a particular structure, and in our case it was roughly square, and you can see these eddies in the bottom diagram, and they can get quite violent depending on the geometry of your structure, and that violence adds vibrations and extra stresses onto your structure. And so you have to be quite careful that your structure is stiff enough to be able to resist all of this excitation, and also that your connections have enough strength. So this is something that we started to understand as we were developing the design a little bit more, that this is a phenomenon that we have to be quite careful about and design well for.
Thanks, Shingi. You make it sound so complicated.
Wouldn't want to make it sound achievable.
But I suppose there's a point in the design process where Shingi was crunching numbers and looking for more ballast and weight to place in the design that we could conceal, and we started really developing this kit of parts as we saw it. The three timber elements, the shipping container, and looking at how this interrelationship between how the materials delivered to site, how they're first formed together, and how they can be transported and reassembled in the future. And so this sequence really just talks about that process of panelized material, the first assembly, then packing it up into the shipping container, or assembling, holding the event, and then packing that up to go to the next location.
From our point of view, we really felt strongly that timber would be a really good material to use for this, because if this structure has to do quite a bit of traveling and has to be durable and see lots of cities and be taken apart and put back together again, then timber is really ideal for that. Because if, for instance, something happens to a particular element during transit or anything like that, timber elements are very easy to replace, or even after a few runs of construction and deconstruction, some elements might start to wear, and they will be very easy to remove from the structure and add a new one. And this is really facilitated by the fact that we're using very simple fasteners that are more or less universal. So I would imagine that a lot of the cities that this could travel to, you could find very similar, like L-shaped connections and strap connections that we've used throughout the structure. So it really helps with accessibility and constructability when you move to a different city and maybe you've lost half of your connections along the way. You'll be able to find something similar in whatever city you find yourself in to put all of this together. And it's really important that this is lightweight, because it would be good to construct this quite quickly for whatever purpose it's used at different locations. And so it being lightweight means that you don't need as many people on site to put this together, and you don't need as much machinery. So you could probably get away with like a crane and a cherry picker, and you don't need a lot of hardware to actually get this up and running. Let me run the animation to explain what you've just spoken about.
So this is an animation that we put together to describe our proposal, really. It speaks of the process of timber material coming from sustainably managed forests to the site, assembled as we've described. And then the day in the life of the timber beacon as it's used as part of an exhibition piece. And then that process of decamping and driving off to the next location.
I still think that's the most adorable animation I've seen in a long time.
So that came together quite nicely following the concept. I thought I'd share some slides that describe the proposal so following the concept stage, there was then a process of, I guess, listening to Shingi and her team about what was needed to stiffen up and hold down the timber beacon, and we were able to work through a certain level of finesse. So these images are really where we got to with that. So it shows this 12-meter cantilevered beam section, which is really important in showing the strength of engineered timber. So this was proposed in glue laminated timber pieces with a splice joint roughly centered, which was quite an interesting junction, I suppose. You can see the exhibition space, which is formed in a rectangle with this slot through the roof, with the idea being that there's quite a lot of discussion within the studio about how we can maintain the longevity of CLT structures when left out in the rain, and being softwood, they are quite susceptible to moisture over time. So the idea that the slot could form a gutter that's formed of a tarpaulin that goes over the top of the exhibition space. But what was really key about the space is that it was quite legible as panelized material, and so you'll notice the open ends at both sides, which are just closed off with some glass screens. We can probably move on. And so this slightly exaggerates the cantilever, but I think talks about the opportunities as a placemaking piece, and also the legibility of the sign or the tower element that sticks above as a telescopic wand above the shipping container, and speaks of the purpose of the structure. So very different aesthetic to the exhibition room as you move around from the open glazed ends to more of an enclosed box, which rather suits the program quite well for hosting exhibitions and having printed material of the like in turn.
There's something about this image that reminds me of a conversation we had in one of the design meetings about being honest about timber moving and creeping and deflecting, and I think I get a real sense of that from this image, because the 12-meter cantilever is quite long, and you were quite brave architects, braver than most, to accept that timber is actually going to deflect and it's going to behave the way that timber behaves, which I think was quite important, that we were trying to get to grips with the actual behavior of the material that we were using at the time.
Yeah, sure. And then the exhibition space being raised from the ground, and this was again really important in terms of the longevity and durability of timber not to come into contact with the ground, and so there's a whole a foundational or footing piece that sits underneath and is set back from the sides. But it gave us the opportunity to integrate some seating and planting devices as well to help animate the edge of the building. And then a view internally. So I guess the purity of the external form is made possible by these glue laminated paired columns and beam arrangement that sit in the middle of the exhibition space and frame the main entrance doors. And so these are doing quite a lot of the hard work in terms of the structure, supporting the canopy above, and keeping the walls upright, I suppose. But it acted as quite a good dividing piece within the space, and obviously structure is really important.
Now we get to the bit where I talk about how we tackled those structural challenges that we spoke about a little bit earlier in the presentation. So the first thing that we had to pin down was the overall stability of the structure. And I mentioned before that timber is quite lightweight. So you have to be very careful about where your mass is and making sure that you have enough mass. And one of the things that we were quite adamant about at the beginning of the design process was we wanted to use all of the components, including this container. And what became apparent as we were doing some of this design was, first of all, without a little extra weight, this would just kind of fly away. So we had to reinforce this structure by adding mass strategically to make sure that everything worked okay. And the container was actually a very important part in providing that weight, because that's the one steel component in the structure. So it's much heavier than some of the other timber elements viewed individually. So we were doing some studies to understand what the centers of mass of the structure were and where we could start to adequately start applying our mass in order to hold this down. So one of the things that came out of all of the analysis that we were doing is that we needed an extra 10 tons of mass to hold this down under quite stringent wind conditions. And we've divided this up between sandbags that we could put underneath the exhibition space, and water and or sand, depending on the availability of the current locale in the container. And one of the things that was really important was the detailing of these three different elements, because the container and the exhibition space are really what's working to hold this down. And so we needed to connect them together and make sure that they act as one. And when we were doing connection details, there's a little sketch of the detail that we've done at the top here. So this bit in the middle is the container, and you can see we've made an opening in that, and we've connected to a separate structural element that is within the container, because it was just not feasible to try and make good connections with the thin framing elements of that container. So ultimately what we did was we had to line the container with CLT, because that was much better performing and much stronger than what the steel was giving us, which I think was perhaps a little bit unexpected, because I think people would automatically assume that steel is strong and it's going to do the job. But actually, when you're dealing with containers, you have to think about that quite carefully. So the CLT ended up saving us in the end. Regarding wind, we spoke a little bit earlier about vortex shedding and about the stiffness of the structure. And we realized that we wanted to make the structure quite stiff, because if you let the structure be not stiff enough, then you really have to start considering quite complex equations and relationships between wind and the structure. So we decided to stiffen this up so that all of those resonance issues and vibration issues wouldn't be a problem. So that was achieved mainly by bracing up the steel container at the bottom, and also having these CLT fins that connect to the sign to provide adequate stiffness. And one of the other things that came out of the analysis that we were thinking about was the lettering actually has a significant impact on the stiffness of the sign structure, which is the part that's most susceptible to vortex shedding. So we had a few conversations about what the kerneling on those letters should be and how high it should sit, and whether we can have lettering on both sides or on just one side. So all of those structural issues had a very big aesthetic impact on what dRMM were also thinking with their design. The other quite important bit that we had to think about in terms of detailing was the detailing of that canopy. So Steve mentioned before that we ended up using glulam for this. And our initial thoughts when we saw the structure was to use LVL, because it's quite high strength and it's very durable in an external condition. But availability issues meant that we had to use glulam. So that also fed into some issues that we'll discuss later about members being thicker, because we're using a material that's strong. So you have to use material to compensate for the strength that we've lost in not using glulam. But we anchored that long cantilever at the back here, and we connected it to the container where we have all of this weight that we've distributed, so that we get good balance on the cantilever. And we also spoke quite a bit with the architect, and we did some calculations on our own as well to understand what happens with this joint, because all of this has to fit in the container at the end of the day. And so we had to think about where it was appropriate to place this joint so that we have as few members as possible, because that helps with construction, but also in a location that's designable. And we'd initially assumed that we'd probably have to have an inserted steel plate with a bolted detail to carry the bending moment at this location. But after doing a few runs of the calculation, we discovered that we could get rid of that extra bit of steel and actually use these layers of timber to create that joint detail, which I think was a positive twist on trying to add a little bit more timber into the project. And then the other key bit that we liaised quite a lot on is the exhibition space. So this has gone through a few iterations, and this is kind of one of the ones that we were thinking of. We started off with 4 frames, and then some of the images that Steve showed earlier, we ended up with 2 in the middle. But we were thinking a lot about the hierarchy of structural elements and how that also impacts the aesthetics and what's happening with our stresses. So in the beginning, we started off thinking about having double beams for these frames and a single column that sits in between those beams, and that made sense at the time because at the edge of the building we were also going to have a balustrade, and that could be detailed so it wouldn't be conspicuous because it can sit between the double columns. But as the design progressed, we moved those frames inward a little bit more, and the CLT started to cantilever, and we decided that actually having a double column arrangement with a single beam worked better, and then we could align these frames. It's not visible in this image, I'm afraid, but there's the long cantilever that sits on top of there, and it exerts a very strong compressive force onto this exhibition space. So those double columns would help with resolving that force.
Great. So I think I just wanted to say, whilst the project wasn't realized, we got quite a way through the technical design to the point that a fabrication model was produced by Derricks, who were lined up to provide all the engineered timber, really. And so that was an interesting process as well, taking our model, then coordinating with the digital model that they provided, and then spotting the differences between two. But this just shows that that level of fabrication drawing where each item is listed out, and I think it's the tower elements that are highlighted there.
I think this was also an interesting process because they were approaching the problem as fabricators, and obviously dRMM approached it as architects and we do as engineers. And so we all had to meet in the middle somewhere and actually come up with some solutions to fabrication issues together to make sure that we could still have strength and good aesthetics, but also construct something as easily as we'd hoped we would at the beginning of the design process.
It's very true. I think that that sense of collaboration worked the whole way through. Having good, friendly engineers and contractors helps. The final point just wanted to discuss really was this idea of how all of this packs into the container, and I suppose there was a whole exercise, or a whole ongoing exercise, parallel exercise probably, with each design iteration, then trying to assemble the component parts into a shipping container, trying to source a shipping container, trying to become experts in the multitude of shipping containers that exist. But in the end, I suppose we didn't quite manage to fit it all into the shipping container, but suffice to say that in an open top arrangement, we could kind of poke out a little bit. So I guess, yeah, just highlighting that process, I suppose.
Yeah. And this was, I mentioned this before when we were talking about the canopy, that actually how the parts and how they all fit together was so important in this final bit. And every time this image didn't work, we had to go back and think about, is this joint in the right place, or is this panel the right size, and does it still work for structure, and does it still look good? So it was a constant iterative process of trying to get us to this point. And thank God for open top containers, because I think we would have struggled otherwise. And that's it from us.
Yes. So hopefully that's been a helpful discussion around the Timber Beacon project, and perhaps also that design process and sense of collaboration that existed to realize the project this far. Hopefully physically at some point this year.
Okay, thanks, Steve and Shingi. That was fantastic. Thanks for the presentation. They're a really interesting little project that, and I think we've had a few questions coming through. I think one was around will it actually be used after COP26, and I think you've explained that it wasn't actually built. So, but hoping to use it for the design festival. We've had a
If I
couple
can
of
just
other.
interject
Yeah, go
there
on,
and
Shingi.
say, I think the original plan was that it would go to quite a few cities, and I think that's a really important point on the project, because we talk a lot about circular economy. We talk a lot about, yes, you can deconstruct and reconstruct, but I don't have a feel personally of how well we can do those things. And actually I felt this was a very good experiment. So you can take it to as many cities, see how long it takes before it really starts to fall apart. And then the next time you take your circular economy conversation to a meeting, actually this connection on CLT lasts about 7 cycles, and then we have to do something about it. So I'm hoping that it still gets to go on that journey, because I think there's this wealth of information that we can get from this whole process. And for me, it's my first time doing something that you can take apart and put back together again. So I think there's quite a lot to learn from this.
That's a really good point. Just before we go on, actually, if you've got any questions, just type them either in the Q&A box or the chat box. Either one, we'll pick them up somewhere along the line. But just on that point, Shingi, with the connections, you said you used standard connections. Were they sort of screwed connections, or were they sort of more quick release type connections? What was sort of connections did you actually use to hold the pieces together?
They're all screwed connections. So there's a variety of strapped connections and L-shaped bracket connections that you would normally find for CLT, because that's mainly where we're making our connections. But we also used bolts in the exhibition space, which I forgot to mention earlier. So those columns and those beams, they're connected by bolts together. But one of the things that now I think we have a little breathing room, we have the opportunity to test this, to see if we can actually get wooden dowels to work. So for the majority of the structure, we're using lots of screwed off-the-shelf connections that should be easy to find. But those exhibition space frames that take a bending moment, we want to play around with that a little bit more and see if we can introduce a bit more timber into those. And then maybe if that works, we might be able to apply that to the canopy as well. But it would be quite nice to test that and see.
Okay, so just during that process then of looking at the connections that were available, and it appears from what you're saying that the connections that you had to use were in effect designed for single use in the first place, and not necessarily designed for multiple reuses. Is that something you feel that companies need to start looking at now for structures, not just like this, but for proper structures that we might have to move around at some point or make more adaptable? Is there a need out there now for more quick release type connections, things that can easily fit together rather than using lots and lots of screws?
Yeah, I agree, because we have used screws, and I can appreciate that in certain circumstances that can be a bit labor intensive, because there can be a lot of them. We've tried to keep them to a minimum. But I think people are already starting to look at this. So one of the fastener manufacturers that we consulted sort of as part of this project, they're already starting to make connections that are specifically designed for deconstruction. So while most people would use these screwed connections assuming that they're single use, they can be taken apart and re-screwed back together. But people are starting to think about more and test and develop more of these connections that allow you to take things apart. And I think one of the really important things actually would be understanding, if we think about buildings, understanding how these perform under fire. I think that's really, really critical, especially given the way design codes are going in the UK at the moment regarding fire design for timber. So people are starting to have a look at this, but we need more. We need lots more.
Okay, just back to some of the questions on from the guests here today. You mentioned your applications, Shingi. That are they available on your website? Where can people download those from or get access to those?
I will put some stuff in the chat. So the route to zero, which you can play around with, we're really hoping for some feedback from everybody, so we can. The idea of that tool is that we want to be able to use it as an aid for research for everybody in the industry. We can only control what we're doing, but we can also use what we've discovered to inform others and to influence others. And so I will put a link in the chat for that route to 0-1. For our scaffold apps and our compass apps, I'd have to get back to you on that one.
Okay,
Some of
no
them are
problem.
publicly available, some not.
Some not. That's fine.
Yeah.
Thank you very much. Just another question here. How was the structure fixed to the ground? Were there any foundations, and if there were they demountable as well?
No foundations in the traditional sense. So I'm just going to go back to a slide that kind of hints at the detail that we had in the end. So like I mentioned before, with a building, you have foundations and you can anchor into the ground, you can embed things into the ground, but we can't do that here. So essentially we're relying on the weight of the structure and its relationship with the ground to cause it to not move. So essentially underneath the exhibition space, we've got a hardwood grillage, and in between these kind of hardwood beams that run along the exhibition space, we have these sandbags, and that's essentially it. So the idea is we just want to be able to place it on the ground and on any kind of ground. And so we're not really relying on anything more than that.
Okay, so and it would just be sort of shimmed up to level
Yes,
based on
exactly.
what was there.
Yeah.
It's really
stuff.
One of the challenges, I think, are not knowing one of the sites for a piece like this, but not knowing where it might end up later, that you need to allow some flexibility for wherever you might end up. Yeah.
Great stuff. Was the species of timber used? What species of timber were used, and what consideration was given to how durable these would be? Another question there.
Yeah, that's a really good question. We did a lot of work during the design process, looking at different timber species that were available. So we've looked at larch and spruce specifically for the cross-laminated elements, as that was what was readily available. And there's quite a bit of work done in looking at a larch outer layer to the CLT, which would provide a slightly more robust outer weathering skin. So that was the direction of travel with that. I think the glue laminated elements are really just spruce, I think, off the top of my head. Maybe Shingi, you know.
Yeah, it depends on availability most, but spruce is a pretty common one to use for glue lam. And in terms of durability, well, I think our biggest concern was really protecting the CLT, because the glue lam is likely to be okay even in an external condition. So there are bits like, sorry, I'm just going to move to a slide so I can gesture if it'll let me. Right. So bits like the top of the sign where the end grain of the CLT is exposed, those were bits for concern for us. So for here, we were thinking about perhaps having a capping detail to make sure that water didn't ingress. And for the exhibition space, we mainly tackled that issue with detailing. So you can sort of see a hint here that we've got chamfered details and we've got lap joints to make sure that no end grain is exposed, and that will always help us with the durability of the main members of the structure.
Okay, thank you. Just on what was the time frame for the project, start to finish? And I'm not sure. I think that whether that's the erection time and the total cost of the project. What was the anticipated erection time for this and design and also design? If you could just state them separately, and then what was the overall cost anticipated to be?
Yeah, it was all such a whirlwind. I need to think back. I think we had roughly 3 months for design, which led to the concepts, technical design, and then coordination with the fabricator, manufacturer. I think from memory, there was 3 weeks fabrication time, 1 week of shipping time, and then roughly a week of assembly on site at the first location. And so what's that, kind of
over 4 months then, basically, isn't it? Well, about 4 months. Yeah. Very, very quick. Great, thank you. Just moving over to the chat questions now. Couple of questions in there around using water as the dead load for the exhibition space. Were there any issues you thought might through leakages to make was that something that you was because you was talking about using water in the bottom of that container, I think, wasn't you? So was leakage thought about, or how was you looking to contain that water?
Yeah, so the at the base of the tower element, or within the container, I suppose, we were looking at kind kind of plastic. I don't know what they're called, gallon kind of.
So like the IBCs type things, or the.
I think so. Yeah, they're used quite often as ballast and temporary water supply. So they're quite robust. So that was certainly something that we were thinking of. The whole conversation around water and timber was an ongoing one, and obviously something we're really aware of, particularly in working with softwoods.
Great stuff. I think this is quite an easy question to answer, probably just a yes, no, because we're running out of time. But should multi-disciplines be involved from the outset of a project?
Possibly. I think certainly in projects like this, the collaboration between architect and engineer is really important. And I think certainly the initial concept needed to be checked, and there was a whole conversation that really needed to happen very early on. And I think probably with all projects, starting that conversation sooner rather than later is certainly beneficial.
Great stuff. Couple of last ones. How was the container erected into the upright position? Assume that was by the crane that would be using everything else as well.
That's right. Yeah. So the animation sequence kind of pick that up in a kind of stop motion sense. It's all magical. But yes, there's a crane that's required to assemble the CLT or the engineered timber pieces.
It's all the pieces together. Brilliant. And then has the beacon been designed to stop people climbing on it? And if so, how was that done?
Yeah, there was a lot of conversation around this as well. And by and large, the scale of the structure would stop most, but the most determined to stop climbing on it. But there's always a challenge around how far you can take these things. So for the level of design, we certainly thought about stopping people walking or climbing up the structure. Certainly,
great stuff. I think that's all the questions, and I think that's spot on time. We're just hitting 5 o'clock now, so couldn't have timed that any better. That's brilliant. So Shingi, Steve, thanks ever so much for your presentation today. That's really interesting. Really appreciate your time and giving up your time to come and present this to us. And I know you've spent a lot of time sort of talking to each other, actually sort of preparing that presentation, and that's what takes longer than the actual presentation itself. I know. So really appreciate your time. Shingi, I think you said if you want to send some links over, whether you send them to me or Jack, and we'll send them out tomorrow, because the chat doesn't disappears after the meeting, so we'll probably easier just to send them out. So if you send me an email, and Jack will send that out with the notes to the attendees, if that's okay. Thanks very much to all our attendees. Really appreciate giving up your time, and hope you enjoyed that presentation. Really enlightening. Just shows where we need to be going as far as designing for a circular economy and designing timber structures. And I think the key one there is the key sentence that came out of there was allowing for the movement and things of timber. So we need to allow that timber does move, it does flex and everything else, and we just need to appreciate that when we're designing timber structures. So I'll just say goodbye and thanks very much for your time, and we'll see you at the next one.